Hello, welcome back to another OMG AS chemistry video. Today we're going to be looking at back titrations. Specifically, we're going to be looking at the analysis, and our goal is to be calculating the purity of calcium carbonate. Sometimes it will be calcium carbonate, they might use magnesium, but a nice sort of hint that we're doing a back titration is that we're looking at carbonates. So let's get straight into it. Now, I've given you a 5-step process to get into that point of calculating purity. First thing I need to do is calculate the number of moles of hydrochloric acid neutralized by sodium hydroxide. So if we look at the question, 0.5 grams of calcium carbonate was added to 25 centimeters cubed of 0.5 mole per decimeter cube hydrochloric acid and allowed to react fully. That reaction is shown in the equation I've labeled 1. This solution was then neutralized by 34 centimeters cubed of 0.1 moles per decimeter NaOH. That is in equation 2. So let's first look at calculating the number of moles of HCl neutralized by NaOH. So I'm just going to analyze this titration. Let's build our titration table. This is for question A. They've told me that I had 34 centimeters cubed of NaOH, and that was of concentration 0.1. They've told me the concentration of hydrochloric acid. I don't know the specific volume that was left over, okay, so I can't really fill in anything. So the first thing I want to do is calculate my number of moles of sodium hydroxide. I'm going to do that by doing concentration times volume. So 0.1 times 34 divided by 1,000. That is going to give me 3.4 times 10 to the minus 3. Okay, so that's my answer to A. I'm going to move this up now. So I've done A. Next thing, I want to calculate the number of initial moles in the hydrochloric acid. So let's look at our initial moles. If I highlight this key information for you, 25 centimeters cubed and a concentration of 0.5. So for B, I'm going to find my number of moles of HCl initial by doing concentration times volume. So I'm going to do 0.5 times 25 over 1,000. And that's going to give me 0.0125 moles. That's my answer to B. Just to check that I've just got that information from the original. So we've done B. Let's move on to C. Calculate the number of moles of HCl neutralized by the calcium carbonate. So for C, I'm going to be using these two answers. Okay. This was my initial number of moles, and this was what was left over after the reaction with HCl. So to find my N neutralized, okay, to find that out, I'm going to take my initial and I'm going to subtract what was left over, which is going to give me 9.1 times 10 to the minus 3 moles. Brilliant. So far, we've focused only on hydrochloric acid. We've now got to calculate the mass of calcium carbonate in the original sample. Okay. Now, we're going to get the mass for D by using the equation N equals M over MR. Okay, so the first thing I need to work out is how many moles of calcium carbonate do I have. So we're going to look straight to that initial equation. We can see for every 1 calcium carbonate, I get twice as many hydrochloric acid. Okay, so if we look what we've got, my original number, or the number of moles that was neutralized from HCl, was 9.1 times 10 to the 3. To find my number of moles of calcium, then I'm going to divide this by 2, because for every 1 calcium carbonate, I get 2 hydrochloric acids. It's going to give me 4.55 times 10 to the minus 3. And I'm going to rearrange this equation to give me mass. I want to work out my mass of calcium carbonate. So I'm going to do the number of moles times the MR, which means I'm going to take 4.55 times 10 to the minus 3, and I'm going to times that by calcium carbonate's MR. So I've got 1 calcium, so 40. I've got 1 carbon, so 12, and I've got 3 oxygens. 3 times 16 is 48. That gives me that my mass of calcium carbonate then is 0.4555 grams. So I've done D now. Let's go back up to our tick list. I've done D. Move it back down so you can copy that in. My last thing they want me to do is calculate the purity. Now, purity is a percentage. I need to look at my original mass. I had a tablet which had a size of 0.5 grams. Of that, 0.455 was calcium carbonate. So my tablet weighed 0.5, of which 0.455 grams is calcium carbonate. Therefore, my percentage mass of calcium carbonate is going to equal 0.455 divided by 0.5 times 100%. Okay? Then we're going to use a calculator to do that. And that is going to give me a percentage of 91% purity. Okay, so that's our 5-step process to analysing a back titration. So make sure if you need to watch any of that again, I would, because there's a lot of complicated steps in there. Maybe watch it through without writing and copying, just work out what I'm doing. Going to give you one to do yourself now. Really, really similar, this one. And then you can check all your answers here. Hope to see you on another OMG video soon.